Types. You got the static typers and you got the dynamic typers, right? And the static typers are all about, getting the compiler to check every type, and you must specify your types and perfectly and to the nth degree. And at first, this sounds fairly reasonable, right? Because you don't want to pass, a double into a function that expects an int. You don't want to do that. You'd like the compiler to tell you, you're doing the wrong thing. And okay, fine. But then what happens? Well, then, you start creating your own types. You start creating types like employee and order and things like that, domain-oriented types. And then you want to put them into lists. Well, in order to put them into lists, you need some kind of generics. So some kind of template language. Okay, well, that seems fine until you start running into the problems of contravariance and covariance and all the nonsense. And then you have to put all these widgets and arcane symbols into your template language, and it starts to get really, really complicated. And in the end, it turns into a Turing complete language that you can execute entire programs in just the compiler without ever running a program. It's just the compiler running your program. And you know what? That programming language is dynamically typed. This is like the worm Ouroboros eating its tail, right? The whole problem, the whole mindset leads to a self-contradiction. But then you've got the dynamic typers, and the dynamic typers are like, we're free, we're butterflies, we can fly away. We don't need types. Oh, the machine will determine the types for us, and it'll convert the types, and life will be beautiful all the time, and I'll be happy to see those nice young men. Oh, yes, yes. Some years ago, a fellow by the name of Capers Jones did a study. It was a long study on various programming languages, and he measured the performance or the productivity of programmers using different languages. And one of the things he found was that Smalltalk programmers were 5 times more productive than C++ programmers. That was a big shock. And of course, Smalltalk is a dynamically typed language, but C++ is a statically typed language. And so there was a big war fought between Sun and IBM over which language would dominate the internet. And Sun wanted it to be Java, which is really just C++ with all the warts cut off. And you've got IBM who wanted to use Smalltalk, and that didn't fly at all. Eventually, the C++ programmers won that war by forcing Java on the rest of the world. And, oh my God! And it's gone back and forth several times, right? So everybody gets all excited about static typing, and then after a while, they get burned out on static typing, and they start all becoming Ruby programmers because that's a dynamically typed language. But then they get all burned out on having type errors everywhere, and so then they start becoming Swift programmers, or it just goes back and forth and back and forth, back and forth. And you know what the answer is? They're both wrong. That's what the answer is. They're both wrong, right? The dynamic people want the types checked at runtime, which is a really bad idea. Because, when the missile is approaching its target, it would be really unfortunate if it threw a type error just, 5 milliseconds before it was supposed to detonate. And then, the static typers want all the types checked at compile time, which is a really bad idea because you wind up with the worm Ouroboros eating its tail. No. Here's the answer. The answer, boys and girls, is to check your types at test time.